So I just wanted to give a couple ideas for you to think about from section 1.5, mostly just an idea of how to find inverse functions. And if you imagine you had an equation that looked something like this, if we have f of x equals, say, 1 over the square root of x plus 2. And we wanted to find the inverse function. There's a bunch of questions we might have. We're supposed to find the inverse function and find a graph of it. First thing we need to do is to check to see that it is 1-to-1, which means that there are not two possible y values that are the same for two different x values, i.e. that it passes the horizontal line test. So let's do a quick sketch of it. Sketching this, if we take the square root of x plus 2 first, we know that that's just going to be the square root function shifted left by 2. So it sits here at -2, 0. And then the reciprocal of that is going to be pretty straightforward. We're going to find the value of the reciprocal of 0 to be undefined. And so we can bring that spot down as a vertical asymptote there, and that is at x equals -2. We can then plot a couple of easy points and then think about it a little bit. We should be able to get the rest of the graph. If I substitute the value of x equals -1, then I'll have the square root of 1, which is 1. So we do have a point here which is -1, 1, and the reciprocal of the y value is 1, so that will also be just -1, 1 here. The intercept is going to be square root of 2, which is 1.4 and 4, so it's a little bit more than 1, the reciprocal a little less than 1, and so we should have a y-intercept somewhere around here. If I take the reciprocal of large y values, they're going to be small, so this is going to tend to the axis, use the axis as an asymptote like this, and the reciprocal of small y values are going to be large numbers, and so our curve is going to take off like this. So there's our equation, and it looks like it passes the horizontal line test just fine, so we should be able to go ahead and try to find an equation for the inverse. And I have kind of a favorite method, which is to think a little bit about peeling an onion. And in this case, the very first thing that's been done to our input, which we often call x, but it could be anything, is that we added 2. And then we took that thing, and whatever that was, we took the square root of it. And then that thing itself we took the reciprocal of. And overall, this is how we end up going from an input to a final output. And if we undo one little piece at a time, whatever that function did, then we should find the inverse. And the last thing done was the reciprocal was taken. So the inverse function, if we're thinking about the inverse function, it should very first off have to undo a reciprocal, which is a reciprocal. And then to undo a square root, we're going to square. So whatever that was, we're going to square it. And then we'll take the first thing that was done, which was that we had 2 added to x, and we will subtract 2 therefore. So there's our recent output, and then we'll take all of that and subtract 2, and then we'll check to make sure this works. So if that's the case, then the inverse function looks like it will be we'll have x 1 over x, and then we're going to square 1 over x, and then we're going to subtract 2. And if that works, then this is in fact the inverse function of x. So we can test that idea. What if we started with, what if x was, say, equal to 3? Then f of x is going to be 1 over the square root of 5. And if we walk over here and we take that as now the input for the inverse, then we'll end up with the reciprocal of root 5, which is root 5. Squared is 5 minus 3 is equal to 3.